So this set of notes is going to look at the trig derivatives. And I am going to end up writing them all out so that you're going to have to memorize them. I would make flashcards to practice. But I like to explain where they come from. So let's go ahead and look at these first few just from graphing. So thinking back to how we graphed the derivatives and that matching activity that I had you guys all do, we're going to look at where our critical points are. So for our graph of sine of x, we have critical points here at pi over 2 and 3 pi over 2. And then my colors back out here. We're going to be positive, meaning above sea level for these sections, and then negative, meaning below sea level for this section. So we're going to be above and then below and then back above. And this is one that we actually had already looked at. This graph is sine and its derivative is cosine. So I'm just going to keep like a running list of all of the derivatives over here. So derivative of sine gives us cosine. So this is the graph of cosine. We're going to do the exact same thing. So here is where my critical points are going to be. So we've got them at 0 and pi and 2 pi. And we're going to be positive for this section and negative for this section. So we're going to be below sea level and then above. So this is not quite the graph of sine. It almost is. What is this the graph of?
Negative sine.
Yeah, good. It got flipped over, so it is negative sine. So derivative of cosine is negative sine. All right, cool. Those two usually go over pretty well. It's when we get into the other ones that it's like, oh, we really have to remember all of these. Here, we actually don't have any critical points. In the middle here, this doesn't ever get quite horizontal. It's going to be like almost down to 0, but not quite. Also, this graph is increasing all of the time. So our derivative is going to be positive or above sea level all of the time. Now, the asymptotes are going to translate those. We have one at pi over 2 and 3 pi over 2. So what we've got is something that's going to be like almost 0, but not quite. And then these tangent lines or slopes would be going up and up and up. Same thing here. They're going to be like really steep, kind of get down to almost 0, but not quite. Like if I drew in tangent lines here, they're really steep and then they're not quite 0. And then they get really steep again. So it's going to be up here, get down to almost 0, but not quite, and then back up. And then that same thing is going to continue on. You're going to get all of these U shapes. So that is not quite the graph of secant. If you remember, secant has the U shapes that alternate, like you have one up here and then one down here. When we turn them all positive, we have squared them. So derivative of tangent, oops, I guess I need an X there, is secant squared. Now, those are all the ones that I have done by graphing, because usually people don't want to graph any more of these. But if we look at cosecant, I can rewrite cosecant as 1 over sine. Cosecant is the reciprocal of sine. And then we can do a quotient rule. So we'll review what we did yesterday. Quotient rule would be the denominator and then the derivative of the numerator. 1 is a constant. Derivative of a constant is just going to be 0. Minus the numerator, which is just 1. And then derivative of the denominator. Well, we just said derivative of sine is cosine. And then that is all over the denominator squared. So like I said, we're going to review quotient rule, product rule, chain rule as we do all of the trig functions as well. So you're going to get plenty more practice with that. Now this first entire part is going to go to 0, so that's gone. We're left with -1 cosine of x over, now this is sine squared, so I'm just going to go ahead and write sine twice. That's what sine squared means. And then to simplify this down, 1 over sine is cosecant. It's just that it's negative. And then does anyone remember, I will tell you if you've all forgotten, but I just want to see if anyone knows, does anyone remember what cosine over sine reduces to?
Tangent.
Cotangent.
Yep, cotangent, good. So derivative of cosecant is negative cosecant cotangent. Now, I'm not going to force you through going through any more of these explanations. I'll just write out what the rest of them are. But if you wanted to do derivative of secant, you could write that as 1 over cosine and then do a quotient rule to see what it comes out to. But derivative of secant is secant tangent. And then derivative of cotangent is negative cosecant squared. So I realize that that is a lot, and I'm actually not done because we have to write down the arc trig functions. We don't have to do all 6 of those though. But let me just draw your attention to some things that you can notice. All of the cosine, cosecant, and cotangent all have a negative. So that's one way that you can remember where the negatives go. Sine and cosine usually go okay. People will just tend to remember those ones. But the way that my brain kind of sorts out or organizes the rest of these, do you see how tangent and secant are kind of buddies? I call them buddies because we don't really have a different word for them, but derivative of tangent is secant squared, derivative of secant is secant tangent. So those two kind of go together. And then cosecant and cotangent are kind of buddies, and they have the exact same relationship. Do you see how tangent was secant squared? Well, cotangent is negative cosecant squared. And cosecant is negative cosecant cotangent. So these two go together and these two go together in a very similar manner. The cos are just negative. And then the arc ones that we have to do, the inverse trig ones, you only have to do arc, sine, cosine, and tangent. Arc sine is 1 over square root of 1 minus x squared. Derivative of arc cosine is the exact same thing, but with a negative in it. And then arc tangent is 1 over x squared plus 1. Whoops, I'm sorry. Or you can write 1 plus x squared. It doesn't matter what order those go in since you're adding. And if you're going, oh my dear, Nicole, I need all of these in one place organized for me, I've got you. On Monday, when we finish the unit, I'm going to post all of the derivative rules all in one place for you. But I think you need to write these down at least once. You're going to remember things better that you have written down. And if you're not doing it right this second as you're taking notes, at some point go and write them down or make yourself some flashcards. I hate teaching memorization because it's like, here, know these, but you have to know them to get through the problems. Those of you that took AB last year, is this like sounding familiar? Are we remembering this sort of? Like,
Yeah.
do you remember memorizing these? Okay.
We had flashcards.
Oh, you had flashcards? Yeah. And I think, you know what, I'll have to look at my Quizlet. I've put a bunch of stuff on my Quizlet. I might have these up there. I'll have to double check. If I do, I will put a link in an update for you guys. And if I ever get a free moment, and I haven't done it, I'll make some. But I would handwrite them and make flashcards because then you're practicing writing them too. So I am going to need to flip this over now so we can actually do some practice problems. So this one is going to involve the product rule since we have 2 separate functions. This is going to be the first function, and then this is going to be the second function. So product rule is the first thing, and then derivative of the second. So derivative of sine is cosine, plus the second thing and then derivative of the first. So derivative of x squared is 2x. All right, next one. This is a chain rule. You have a function inside of another function. It's like a cosecant got hungry and ate 2x squared plus 3. In my brain, this is like welcome to my internal monologue. I always think of like, do you ever see one of those cartoons where like the medium fish eats the small fish and then the bigger fish comes by and eats that fish, and it's like they're all one inside of each other? Or like the nesting dolls, like those Russian nesting dolls. Anyway, that's what this reminds me of. The outside function is cosecant. So we're going to do that derivative first. And derivative of cosecant is negative cosecant cotangent. Now here it just says x, but we're going to have to put all that stuff that was in the problem. So it is going to be negative cosecant of that stuff, cotangent of that stuff. So that's the derivative of the cosecant part. And then the chain rule is I'm going to have to chain on the derivative of this inside part, which would just be 4x. And believe it or not, that is all just one term, because all that stuff is just being multiplied together. So that's like all one thing. This is another chain rule. There's going to be 3 links in the chain. The most outside function is the 4th power, and then inside of that is the cosine, and then inside of that is the 9x. So we're going to have 3 links in our chain rule for this. So we're going to do the 4th power first. Power rule, that's going to come down and be out front. We're going to drop it to a 3, and everything else stays the same. So that takes care of the 4th power. So we're kind of done with that. So ignore that now. Now we're on to the cosine. Derivative of cosine is negative sine. And again, the inside stuff stays the same. And so now we're done with the cosine. So kind of ignore that. And then derivative of the 9x would just be 9. And again, this is all one term. This is all just stuff being multiplied together. Now this one is 2 separate terms, so let's just do this, and then we'll put a subtraction, and then we're going to just do that part. So this is almost like 2 separate problems, like a part A and a part B. So first is derivative of secant. Derivative of secant is secant tangent. And that was just of x, so there was no chain rule there. So that takes care of that first part. Minus, now this is a chain rule. The outside function is the squared, the inside function is the tangent. So just like over here, how we brought the 4 out front and then it dropped to a 3, we're going to bring the 2 out front, and then this power drops to a 1. You can write it if you want to remind yourself that it's now a 1, but it's not necessary. So we brought the 2 out front, that dropped to a 1. So ignore that. Now we're going to do the derivative of tangent. So chaining on here, derivative of tangent is secant squared. Are you guys hanging in there? Or any questions so far? Am I going slow enough, or are we good? I don't know where we're at. Like, any feedback?
I'm having fun.
Okay. Do you guys like, those of you that took this, do you like derivatives better or integrals better?
Derivatives.
Yeah, probably.
Okay. Did anyone say integrals? No, I like integrals better. So we'll have to see if I can like change anyone's mind when we get there. All right. This is a quotient rule. So quotient rule is the denominator times derivative of the numerator, which would just be 4, minus the numerator, and then derivative of the denominator. Okay, cotangent. It's a co, so I know it's going to be negative, and it is negative cosecant squared. There's not a chain rule because it was just x. And then this is all over the denominator squared. This one is about as difficult a problem as I could possibly make. A lot of people want to know, like, how hard is this going to get? Probably this. This is about as tough as I can make it. This is the first function. This is the second function. So there's going to be a product rule. And then this one has a chain rule inside of that. Okay, but we're going to do product rule first. So product rule is the first thing. So that'll be sine of 5x squared times derivative of the second. So derivative of secant is secant tangent. So that's first times derivative of the second plus, I'm not even going to try to make this fit. I'm just going to come down to the next line. This is plus the second thing times derivative of the first. And so now we're going to do the derivative of this, and it's going to involve a chain rule. So the outside function first, derivative of sine is cosine, and that inside part stays the same. And then you chain on the derivative of that, which would be 10x. So it was first, derivative of the second, plus second, and then all of that is the derivative of the first. All right, and then here are the two inverse trig ones that I put on here. Arctangent is 1 over x squared plus 1, or you can write that around the other way if you want to. Okay, so for this problem, that will be 1 over, now I know the rule says x squared, but it's going to be this stuff squared. So if I square 7x, that will be 49x squared, and then it's plus 1. And now there's a chain rule. You have to chain on the derivative of that stuff, which would give you a 7. Now I'm going to clean that up a bit. You would usually just see the 7 written in the numerator instead of off to the side like that. And then this one, arc sine is 1 over square root 1 minus x squared. And again, this says x squared, but it's going to be whatever stuff is there squared, just whatever's in the problem. This is like the general rule, and then you have to apply it to the problem that you're doing. So 1 over square root 1 minus, now it is this stuff squared. So 3 squared is 9, x squared squared will be x to the 4th. And then I'm going to chain on the derivative of that stuff. But instead of writing it off to the side, I'm just going to go ahead and put it in the numerator. And the derivative of that would be 6x. So now you're like, oh no, these ones have words in them. All right, this says write an equation. To write an equation of a tangent line, you need two things. You need a point and you need a slope. So our point is going to be pi over 3 comma something. And so we're going to plug pi over 3 into this function. Now, if you plug in pi over 3, the 3's are just immediately going to cancel, and all you have is pi. So on your unit circle, pi is right here, the point -1, 0. We're going to do cosine of that. So is cosine the x coordinate or the y coordinate? You can type in the chat. Does anyone want to give it a guess, or do you remember? Which one gives us cosine, x or y?
X.
Good, x, which would be -1. And then we have to take that to the 5th. -1 to the 5th is -1. So I took pi over 3, I plugged it in, I used my unit circle, that's my output value. Slope comes from the derivative, so we're going to have to do the derivative of this. This again is going to be a chain rule with 3 links in the chain. The power comes first, so that 5 is going to come down, it's going to drop to a 4, everything else stays the same. Next in the chain is the derivative of cosine, which is negative sine, and everything else is going to still be there. And then lastly, the derivative of 3x would just be 3. So that's our derivative. To get our slope at this x value, we're going to have to plug in pi over 3. All right, so let's see what that gives us. Again, the 3's are going to cancel. That would be pi. We said cosine of pi was -1. If we take that to the 4th, it will be a +1. And then 1 times 5 would be 5. So we get 5 for that first part. Multiplication. Plugging in pi over 3. Again, the 3's are going to cancel. Here's pi. Sine would be the y value, which would be 0. We can't negative a 0, so that's just 0. And then times 3. And so since we have a 0 in there, 0 times anything is just going to be 0. Now, I realize this slope came out to 0, so that really kind of shut down the whole problem. But just for the sake of reminding us all of the format of the equation, I'm still going to write out the same thing for consistency's sake. It would be y minus -1, so that'll be +1, equals the slope, and then x minus pi over 3. Which I realize obviously all of this would just be 0, but I'm just trying to be consistent and write out the equation the whole way. Because what if it wasn't 0? Then you'd have to write it out. All right, and then last one of these. At what values of x does this function have a horizontal tangent line? So horizontal means like this. That has a slope of 0. So 0 slope. And so we're going to find the derivative and set it equal to 0. And then we'll solve. So this derivative, derivative of just x would be 1. Derivative of sine is cosine. And we're going to set this equal to 0 because horizontal means 0 slope. So subtract over the 1. And so we need to find a place on our unit circle where cosine is -1. Cosine's the x value, which actually I'm not sure why I redrew this because it's actually going to be the exact same picture I have up there. But what was that angle? If we rotate over to here, what is that amount of rotation?
Wouldn't it be pi?
It would be pi. And so that is your answer.